Thank you. My name is Scott Herzog. I'll be going over some ways to use SciFinder-n to uncover state-of-the-art analytical methods and associated validation data. I'm going to start with a reference search here, and you can see I'm going to use detection. I'm going to use Boolean and melamine. You can see the auto-suggest there, but I'm just going to use that Boolean and melamine, and you'll see the relevance sorting, the relevance ranking. I'm looking really good. Detection of melamine, melamine detection. You can see that it's also highlighting analytical, so it knows those synonyms, analytical methods for detection of melamine. I'm going to go ahead and load more results. These are the most relevant. I'm just going to add them all in here. And I just want to see recent ones. You can see there was the big melamine in 2008 was when there was the big melamine adulteration of infant formula, and that's what set off this big peak here. I just want to find out what the latest analytical ones are, maybe just since 2018 to date. And that way I like doing that because then I can leave the relevance ranking on up here and see the most relevant ones up here. And I'm seeing, again, efficient detection of melamine, I might start, as I get down here, start to see things, melamine detection still, where melamine is being used, like this one, to detect dopamine. So since SciFinder-n is aware that melamine is a substance, you'll see that we have the substance roles up here, and analytical study is one way to narrow those down. If we view all, occurrence could also be a way to see those where somebody is looking to find out where it is in the environment, where it is in a body, that type of thing. So using both of those substance roles will help ensure that the melamine is what's being detected here. And I can see there's a lot of interesting things going on here. We've got pegylated gold nanoparticles, another one with gold nanoparticles, quantum dots, and you'll start to see with detection, a lot of times we'll see those limits of detections, 12 nanomolars, 3 nanomolars. And there's nanopores, multi-wall carbon nanotubes. So a lot of really interesting things going on in that field. And here's a continuous real-time detection in flowing whole milk from just a couple years ago there. And one of the things you will notice, probably you'll see this highlighting of methods now analysis. That's also a filter we can use here to get down to the papers. And Daryl and Jean are going to go into methods now analysis more in depth. And if you've seen our presentations before on methods now synthesis, where we save you the trouble of seeing that something mentions detection of melamine, but you want all the steps, you go to the full text and it turns out it's not there. This is a way to keep from having to go through all of those papers where they may be referring to another paper for the step-by-step analysis. Anything that has this methods now analysis will have more detail about that. If we go into the detail of this particular record, you'll see in addition to the concepts, the Medline subject headings, the substances, here we can see melamines and analyte, but we've got the methods now analysis section now. And so this tells us that this one is definitely looking at analysis of melamine in milk by atmospheric precipitation. This is a specific link to methods now analysis for all those details. It'll be a step-by-step analysis. And like I say, my colleagues, Daryl and Jean, are going to go into that in much more depth in just a few minutes here. But we can go back to results here. And so that's a nice way to filter those down. I can also, even though I've done this methods now analysis, if I decide I want to reset the time and go back through all time, and see all of these. While I still have this methods now analysis, now I have 538 of these where I know there's, when I go to the full text, if I wanted to limit to those that I can get right now, now I've just got 53 where I know I'm going to be able to see that detail in that full text of an analytical method. Another couple of things to think about, the detection is going to get a lot where they're talking about limits of detection, but that is something in the concepts. If I deselect the digital copies and the methods now analysis, get a larger answer set here, and I just wanted to show that some of the terms or concepts that our analysts add to these papers, and remember they read through the supplementary materials, it's not just the title and the abstract, but you will see things like limit of detection, sensitivity and specificity, sample preparation, in addition to the actual analytical methods and pieces of analytical methods like quantum dots and analytical test strips. You'll see those ways to narrow down if you want to narrow down to those ones where you're sure that someone has said limits of detection is an important concept for this particular paper. Now, if I'm wanting to look at validation of these particular methods, like for detection of melamine, a nice way to do that is I've got my answer set here. I am looking at analytical studies or occurrence, and I can use this search within to find validation. I've already typed it there, so you can see validation and narrow down my answer set. And so now I'll see where they are mentioning detection of melamine, and they're mentioning validation in here, used reliably, the tests are validated, detection, analysis, and sometimes it's in the concepts they may be talking about validation there. Again, here you see melamine is the analyte. It's part of the analytical study and the occurrence roles, and that's what we narrowed down earlier, but the method was validated. You can go through from the detail of one reference to the detail of the next here, and you get method was validated for linearity. So that's a nice little way to search within to make sure you have all the concepts you started with, and then you're looking at ones where the method was validated in particular. And with that, I'm going to turn it over to Daryl for the next section, and he will show how to use some more advanced features of SciFinder-n for analytical methods. Thank you. Daryl?
Thank you for that great introduction. My name is Daryl French, and we're going to be going through a case today where we're giving information on an unknown, and we want to determine how to set up a system where that unknown may be separated from its other constituents. The two pieces of information that we're given are a molecular formula and structural information that this is a flavonoid. So making sure that we have substances highlighted here, we're going to do an advanced search for our molecular formula piece. We were provided with the molecular formula, which is C15H10O7. This goes in Hill order with examples here, and we also have a webinar, Advanced Substance Searching, which we will show where to find later on. We could add other information such as substance properties from the selectable list, experimental spectra also from the selectable list, but we're only given two pieces of information, molecular formula and some general structural information. So let's go ahead and press the magnifying glass button. And that gets us to a substance set that we have 259 candidates. From what we'll see just looking at the substances, we have the highlighting for the molecular formula, which is great. We do have flavonoids here at the top, which is good, and it appears that we're on the right track. But to make sure that the results are the most relevant that we're going to get from the reference set, we want to narrow this down just a little bit more before we take that next step. Moving down, we'll see that there are some instances that we'll have to be aware of. So we're going to search for flavonoids, but we want to make sure that we also cover the possibility of this incompletely defined substance. But what we really want to eliminate as we go further down the list are components such as these three phthalic acids type compounds. They don't have the flavonoid core. They do have the molecular formula, but we want to get away from these compounds because they're not of interest to us. And this is where we're going to leverage the search within capabilities that we'll see up here on our left filters. We have the search within here, and we're going to draw the benzopyran ring system as a feature of this structure. Using the ring templates to the right here, we'll go ahead and draw, putting in our oxygen carbonyl group here and the oxygen in the ring system. I'm going to point out one of the features that you may want to use when you want to broaden on a structure search, and that's the unspecified bond. This allows you the flexibility to not know the exact bonding order, but to just indicate the overall scaffolding of a compound or a component in this particular instance. It just allows flexibility with respect to bonding order. Single, triple, double bonds are not taken into effect, just the connectivities that we've indicated. I will also point out one other feature, and we're not going to use it today, but that's the lock ring fusion or formation. Within our search, we'll get isoflavones. Now this is okay today because it's something that I want to see. But if you're finding that your ring system or your chain system is embedded within another ring system, you can click on this button and it will change your bonds from normal to bold. And this isolates from further ring formations that you're not specifying yourself. It can be a nice tool to narrow down search results when you're getting ring systems that you don't want, that are appended to the functionality you desire. But we're going to undo that because I'm okay with the isoflavones. Let's press OK. We have two options, as drawn or as a substructure. We want this as part of our structure, so it's a substructure search. We do a find, and we'll notice that our highlighting has changed. Instead of the molecular formula being highlighted, now the structural element that we searched upon is highlighted in blue. We'll see indeed that we have that overall scaffolding, and as we go down, we'll see that the compounds look relevant to our original search. We still have our incompletely described substance. We'll go down even further, and we'll see that we still have the isoflavone that I was interested in maintaining. This would be that instance where if you wanted to eliminate that, you could lock the ring fusion, and that would eliminate this answer and answers similar to it. Going back up, we're going to use the ability of SciFinder-n to directly get the references for all of these compounds. Now remember, we're looking for these unknown compounds and finding references on how to separate them out. We're on track with our molecular formula and our structural units, but now we need to do text refinements on the references that cite these compounds. So under the References tab, we're going to click here, and we're going to get all results. This will open a results set of references that mention each of these compounds, and we're going to further filter those down. It is indeed something I could do in a new tab if I wanted to, but we're just going to go with a linear progression today. We'll get to a set of bibliographic records that cite those compounds. This is a large set, and we're going to be able to filter this by certain features. I really want to focus in on the substance role. I'll do a view all here. We can see all of the substance roles that appear in this set and the numbers that correspond to each one of those. With respect to my unknown, I was looking for a way to separate that out from the other components. So I'm going to be looking into an analytical study, and this corresponds to the approximately 7,000 publications that deal with the substances that we originally searched for, but in an analytical role. The substance roles are assigned by a CAS analyst, and they attempt to capture the essence of the paper and the work that was done on the compounds of interest. Moving down a little bit more, we have other filters that we could focus in on, such as looking into concepts such as flavonoids or HPLC. But I wanted to focus in on the search within results again, but this time with text considerations. This approximately 7,000 results is too much for me to analyze on my own, so I'm going to use specific features that I would like to see. I have an idea of a mobile phase that I would like to use of water, and I would also like to use methanol as solvents. I'd like to point out that when you do a text search like this, of course it searches the title and abstract, but it also searches keywords, the CAS concept headings, as well as registry information such as chemical names, or if you wanted to use a registry number, you could if you'd like to. We'll see that every one of the filters is an active analysis, and so those values have changed off to the side here. When we go down, we'll see that our top 5 concepts have been narrowed considerably and focused in on possible analytical techniques or also substance concepts as well. I believe we have flavonoids covered already with our substance search that we did as a basis. So we could focus in on concepts that would help us narrow down. And this also is part of the enhanced indexing by a CAS analyst, which captures the essence of the paper. Not only what do they mention, but what do they actually study? These can come from tables, they can come from the supplemental information, but they are pulled by a human indexer to try to make it apparent in the focus of the study on the paper. Do a view all. We have a search capability where we can search. We can do an HPLC. And we find not only those top hits of reverse phase and HPLC, but also different considerations that may be useful to us, like tandem mass spectrometry or the stationary phase that they have studied. If I wanted to go back to my top count and make another selection, chromatography, a high pressure liquid, we'll notice that from page to page, our selections are remembered, so you can continue to build your search based on that intellectual indexing by the CAS analyst. Pressing apply, we've narrowed this search down considerably from the 54,000 publications, now down to 327. We could continue refining and filtering the set if we would like to. I'll point out that we have the save option where we can be alerted to new publications that match our current search criteria. We can also add the tags. Canceling out, we have the ability to email this search as we see it to a colleague or any other user of SciFinder-n through the wizard here at the top. And we also have the export options. We have different file types and different processing you may be able to do offline. But what I really want to focus on is the indexing and methods now analysis. I can access methods now analysis right here from this link, but I'm going to dive into this publication and take a look at it. We'll see bibliographic information, text highlighting for what we have searched upon. In addition, full text access options, which are based on the subscription that your organization has. Going down, we'll see the substances, and we have those flavonoids connected with that specific role that we wanted to see of an analytical study, or in this particular instance, also an analyte. But methods now analysis is indexing and analysis specifically designed from an analytical chemist's standpoint. Clicking on the link for Methods Now Analysis automatically takes us to a new tab where we'll be able to see the details reported in this paper for how this analysis was set up and executed. Specific materials that were used, including access to their structure information. Materials from commercial providers. The source, which includes all bibliographic information and abstract, but then a step-by-step procedure on how to create and replicate the system that was used for this analysis. We include the information that was reported in this paper so that you may not have to go and get access, but may be able to run this analysis in your own lab with included validation information and whatever information was included for this specific analytical process. Please let us know if you'd like more information on Methods Now analysis, and we can have one of our trainers follow up with you. And with that, I will hand over the presentation to Gianna, and she will describe a little bit more about Methods Now analysis. Thank you very much.
Thank you, Daryl. As Scott and Daryl mentioned already, there's also Methods Now analysis available as standalone product. So instead of starting your search in SciFinder-n, you could also immediately go to Methods Now analysis to start your search there. You can log in with your current SciFinder login ID and password under methodsnow.com. In case you have not access to the standalone tool of Methods Now analysis, please feel free to contact your customer success manager and he will be happy to help you further. So what we see here is in the starting page a quick search bar and the option to browse through different categories. Let's first have a look at this quick search bar. So when we pick up the food contamination search with melamine that Scott just showed you, we can do a search on the analyte, melamine, and you see that you also get some suggestions, melamine or also melamine resin, but we are interested in the small molecule melamine. Hitting search will give us 1,400 analytical methods. So these are not references you see here, but analytical methods that we indexed intellectually out of full text references. So what you will find here are full analytical methods, so that you don't have to go to the full text anymore to read through the reference and find the analytical method there. So you can just pick the analytical method out of this tool here. On the left-hand side, you see filter options like analyte, and you see that we have 856 analytical methods with melamine as the analyte. Why did we find more initially? Because we did a keyword search throughout all different search fields we have available in Methods Now analysis. So let's filter down by melamine as the analyte. And going down that list of filters here, we also see metrics available. So we see here milk, human milk substitutes, and also a view all link. Clicking that will open all the different matrices we have available in alphabetical order, but we can also order this by count. So let's select milk, human milk substitutes, and what we see also is when we go a bit further down is infant food, which might also be interesting for the background that this was found in milk substitutes. And maybe we can also take skim milk as an addition with 10 analytical methods. Let's click apply, and this will refine our search to those matrices. So where melamine has found in those matrices we selected here. We also see a method category filter option where we definitely would like to do food analysis. So let's filter down by this. And we also can filter by the specific technique. You also see here by opening that filter that we have different types of spectroscopy or extraction methods. But let's have a look again at all these techniques that we have available. And we now can have a look by the alphabetical order because I'm specifically interested in HPLC. When we go down to H here on the right hand side, we see HPLC, but we could also limit to HPLC in combination with specific detection methods. So I'm selecting this additionally, but you could also select only HPLC with UV detectors. Or let's have a look at tandem mass spectroscopy in combination with HPLC. We also have high performance liquid chromatography indexed because this has been found as this in the reference. High performance thin layer chromatography is maybe not what I'm interested in. So I'm going further with these 4 selections and apply the filters. So now let's have a look at the different methods. So we can first scroll through the answer set to see in the overview what might be relevant equipment that we have available, or we can also click on the title and opening this to review this in more detail. You will see a title that is not the original title of the reference, but the title that our indexers gave to that method. We also have the methods number. This is the number you will find in SciFinder-n with the link to Methods Now analysis. We have the table of materials with the different analytes, matrix, material, and reagents. And you can also view the structure. So here we have our monomer of melamine. Here in the source details, you will also see the original title of the reference. You can also go to the full text options, and you will find an abstract that is enhanced to better reflect the analytical method so that you understand better what the analytical method is about. We list the equipment used, the different conditions, and the step-by-step instruction so that you can go ahead and prepare this sample as is described here and to replicate the analytical method. Validation data is displayed as available in the reference. So here we see the limit of quantitation when we go to the next method. scroll down, we might see additional data or even other data. If you would like to compare different analytical methods, you have the chance to add up to 3 analytical methods to the comparison. Add to compare, and then you see here in the right top corner the option to go to the compared methods. Let's expand them all. And here you can then very nicely compare what analytical method suits best. You can have a look at the different equipment used to make the method fit to your needs. And here we also see that for the third method, we indeed have a bit more validation data. So maybe we would like to have a closer look at this. You can also download this comparison with this box with the down arrow, either as PDF or in an Excel format. So that was the quick search. We also have the choice to choose the advanced search, where we can from the beginning specify melamine as the analyte. And we also can immediately specify either with and or not combination the matrix, milk, and you can also add additional search criteria, for example, in a keyword search. Let's say our equipment is mainly from waters, so we can have a look at methods that have waters in any relation, so anywhere shall waters be mentioned. So when we now submit the search, we end up with less results because we specified this further. And we can have a look at this first analytical method, where indeed our search hit on the equipment with HPLC systems by waters. The third way to start your search is to browse by different method categories. So here we see different options. And when we, for example, would like to have a look into biomolecule isolation. So in general, we are interested in methods how to isolate biomolecules. We click further and have the choice to select biomolecule isolation assay, or natural product isolation analysis, or protein analysis. I'm going ahead and click the second one here, and we'll see all methods that fit into that category. So when we have a look at the method category, we now see on top natural product isolation analysis. Under the analytes ordered by top count, you see quercetin as the third option, and this sounds familiar for me because Daryl already searched for that compound or around that compound, so I'm going to select that. And what's now very interesting is the options of different matrices. So where do we actually find this compound? And when we click on View All and have a look by count, we see leaf, flower, stem in general. And going a bit further down, we see, for example, Psidium guajava, which is the common guava. So that's pretty interesting to see the fruit, the specific fruit that is mostly reported as a matrix for that compound. Apply. And now have a look at the techniques again to see if we find some nice analytical methods with HPLC methods. So we see here HPLC and maybe reversed phase HPLC would be good to select as well. We also see reversed phase ultra performance liquid chromatography. So okay, let's have a look at ultra performance liquid chromatography too and select this one as well. Click apply to refine our answer set. And now we see 45 analytical methods that hopefully fit our need to reproduce that analytical method. I hope you found this useful.